Today we've got a Nintendo Switch OLED version, and it's got some problems. Apparently no power, so I'm going to plug this in to my amp meter here and see what happens. I was getting an odd number of volts, and it was pulling something crazy like 3.5 amps. You see that when I unplug it? It flashes on the screen just for a second. About 4 volts, 3.9 something, and pulling 4 amps. So there's definitely something wrong with the charging system here, or possibly maybe even something worse. My guess is going to be the charging IC or something else. I went ahead and took the back panel off here. So let's disconnect the battery carefully, and we'll get this under the microscope and see what's going on. One thing about the OLED version is that you cannot access the primary charging IC without taking the motherboard out. So what I've got in the habit of doing here is checking a few things. So we'll start in diode mode here. I'm going to put my red probe on ground, and we're going to look at the positive side of the battery terminal. And as you can see, we've got a decent value there. That is probably within spec. Okay, so from here, if we go across, one thing that I've been seeing quite often here, you can check this coil. So again, I'm going to put my red probe here. We're in diode mode. And if we touch this coil, you can see we're getting a very low diode value, 0.090. And I've seen this quite a few times. This is very consistent. So this tiny little diode right here, right over here, when this thing goes bad, it tends to give a value of like 0.08, 0.09, just like what we're seeing right here. So my guess is going to be this diode is probably bad. Now the question is it the only problem? And I suspect it's not. I don't know this for sure, but I think what happens is that maybe this diode fails, and when it does, it damages the charging IC. It could be the other way around, could be something completely different, but usually when I have to remove this, we've also got to replace the M92T36. So we'll start by pulling the board out. I'm just going to go ahead and skip ahead so you don't have to sit through that process. I'm going to start by removing this diode, and if you are going to do the same thing, we'll move this little heat dissipative pad out of the way. But also, one thing you want to watch out for in this general vicinity is this connector. So this is prone to melting. If you hit that, if you're using your hot air right around here, good chance you're going to melt that. So I would recommend being very careful in how you direct your airflow, and or putting something over this to insulate it. I'm going to use some of this copper conductive tape, cover that up, and hopefully keep that out of harm's way. And then we'll go ahead and get this off. Alright, I'm going to take that metal tape off. As you can see, still got a little warm there, but nothing too bad. So let's take a look now and see what we have right here. So we are back to close to 0.300 in diode mode. So I can say conclusively that diode was definitely an issue. Now, will we be able to charge the switch? That is the question, because again, a lot of times you'll have more than one problem when you find them this way. And before I plug it in, I am just going to go ahead and check and see what kind of values we're getting around the charging IC. So let's see. Alright, 0.337, 0.5, 0.34, 0.5, 0.4, 0.256, 423, and 0.446. So it looks like at least there is no short, at least not where it usually shows up. So I guess we'll plug this in and see what happens. Okay, so I've just got a battery plugged in. That's really all we need. I do know that this battery has some charge on it, and we'll plug it into the meter here and see what happens. And we have nothing again. So that's interesting. Okay, I'm going to check this with the USB-C meter. And maybe this will tell us where the fault is, with any luck. Zoom in a little, as far as I can zoom. Okay, so you can see we have a very low value on pins 4, 16, 9, and 21. Those are at 0.07. That is definitely not going to be good, and that is likely, well, basically we have a low value. It's not completely short, but it's fairly close to it. Alright, it doesn't look like anything's cross-wired in here, but there could be some corrosion maybe inside that's causing that. I hate to do a port for, oh, look at that. Okay, well, there you go. So we've got corrosion way in the back of the port here, and that is almost definitely what caused the diode to fail, which appears maybe this time to have protected the charging IC. So let's clean this up and see if that low value goes away. Yeah, getting moisture inside here, definitely going to be a problem. And hopefully it only affected the back, these pins. So if that's the case, we will not have to replace the port, which I was kind of thinking would be the next step. Alright, can we clean this all the way back? Make sure there's no corrosion hiding inside there. What do we do? Ultrasonic it? I think I got most of it. Just got a tiny bit of debris back in here and here. But as long as we neutralize this and or remove it, I think we'll be okay. Let's see if that changed our values at all. Okay, so what's happening here is we have a partial, almost 100% short right here. And the good news is, if we remove this filter, we will be able to determine if the short is on the charging port side or on the charging system side. If it's over here, my guess is going to be the charging IC. If it's over here, then we need to replace the port, which I'm leaning towards the port being the issue. But we can save ourselves a little bit of time just by temporarily removing this and seeing which side our short is on. Alright, well, I didn't want that to tip upwards, but that's okay. At least now we can check. And see, with any luck, it will be over here. So, that means our short is on the charging port side. Sorry, my fingers are in the way there. Okay, so the short is on this side. And over here, we have a good value. So I'm going to lay this back down. We'll replace the charge port, and we should be finished, hopefully. What is going on here? Doesn't want to let go. Alright, I want to take a look at this before I clean it up. Yeah, it looks like we have some corrosion in there quite a ways. I have to fix these things up. This got a little bent out of shape, and I blew the other one off on the other side. Not a big deal, but I'll take care of that before we put it back together. Let's clean up this area. That's going to be a little trickier. Alright, so we should have a good value here. That fuse has to be good. Yeah, okay. Put the new port on and we should be ready to go, hopefully. And this is our old charge port. Of course, the back pins have a bunch of crap inside there. So that one's going in the trash. Get our new one prepped. Just want to make sure these back pins have plenty of solder, since we won't be able to see them when it's being installed. Alright, let's get this thing back on. You know how useful it is, but Nintendo seemed to think so. Do this without melting the port off. That's the idea. Ah, too much air. Alright, where'd you go? There it is. Alright, I'm going to have to change my direction here. Hold this thing in place. Better tweezers would be nice. Yeah, I probably could do this with the iron, but that's alright. We are on. I might touch it up. Alright. I think that'll be fine. Clean this up. Hopefully, our charging port is ready to go. Alright, so I might add a bit of solder right over here to this side. Probably doesn't need it, but it won't hurt. Alright, let's check the meter's value again. Right, and hopefully you can see Actually, I'll bring this closer to the camera. So we've got normal values restored, and hopefully this thing will start charging now. Find out in just a second. Okay, it looks like it just booted up. As you see, it went from half an amp up to close to 1 amp, and it looks like we are now charging again. So we'll put this back together and call it done. Alright, so gave that a little time to charge up, and as you will see, we are back in business. Flip that over and make sure it's charging on both sides, and there we go.